NASA's interest in deep ocean exploration stems from its ongoing research into extreme environments that may have parallels with other planets or moons in our solar system. These extreme environments can provide clues about the origins of life on Earth and help scientists understand where and how life might exist beyond Earth. NASA, along with the National Oceanic and Atmospheric Administration, NOAA, is exploring the depths of Earth's oceans to better understand these extreme conditions. One of their projects, the Extreme Environment Mission Operations, NEMO, involves sending astronauts and scientists to underwater habitats to simulate space missions. Additionally, NASA is utilizing autonomous underwater vehicles, AUVs, such as Orpheus, designed to dive deep into the ocean, up to 10 kilometers below sea level, to explore uncharted territories and study life forms that can survive in extreme pressure and darkness. The reason NASA and NOAA are venturing into these deep waters is to study organisms that live in such high-pressure, low-light environments. These organisms may provide insights into how life could exist in similar conditions on icy moons, like Europa, one of Jupiter's moons, or Enceladus, one of Saturn's moons, where liquid oceans may exist beneath icy surfaces. While there is no direct evidence of alien life in Earth's oceans, the conditions found at these extreme depths offer valuable clues about the possibility of life existing in similar environments elsewhere in the universe. The mission deadlines for these projects, as mentioned, have been extended to ensure thorough research, which may lead to significant discoveries in oceanic and astrobiological sciences. This research also addresses the broader challenge that humanity faces in understanding our own planet. Even though oceans cover more than 2/3 of the Earth's surface, we still know more about the surface of the Moon and Mars than we do about our ocean floors. The challenges of exploring the deep ocean, like extreme pressure, darkness, and the harsh conditions, make it a difficult, but rewarding, mission for both NASA and other scientific organizations. As for the Titan submersible incident, it highlights the dangers of deep-sea exploration, as pressures at great depths can be extremely hazardous. The extreme environment and pressure are what make both space and deep-sea exploration so challenging and fascinating. NASA's focus on deep-sea exploration is directly related to its quest for understanding alien life. By studying Earth's deep oceans, where extreme conditions similar to those found on other planets or moons exist, NASA is building its knowledge about how life could develop in such environments elsewhere in the solar system. The deep-sea environments of Earth are where scientists believe life first began, and NASA uses this as a proof of concept for extraterrestrial life. Life on Earth started in areas with 3 crucial conditions. Water. Liquid water is essential for life as we know it. Energy. Life needs a source of energy, whether it's sunlight or chemical energy. Chemistry. The interactions of elements like carbon, hydrogen, oxygen, and sulfur are fundamental for life to emerge and evolve. The same principles apply when searching for life elsewhere. NASA's ongoing exploration missions in the solar system, such as those targeting Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, focus on finding environments that have liquid water, energy sources, and the right chemistry for life. These moons have oceans beneath their icy surfaces, similar to Earth's deep oceans, and might host microbial life or other forms of life. NASA is working on advanced missions like the Europa Clipper and potentially future missions to Enceladus. These missions aim to confirm the presence of water and study the chemistry of these distant oceans to see if conditions there are conducive to life. In short, NASA is connecting its research of Earth's deep oceans to the search for alien life. The idea is that understanding how life began and thrives in Earth's extreme ocean environments could provide clues for finding life in the deep oceans of icy moons or planets in our solar system. In the depths of the ocean, far below where sunlight can penetrate, life doesn't rely on sunlight for energy as most life forms on Earth do. Instead, there are other sources of energy that sustain ecosystems, particularly in areas known as hydrothermal vents. These vents are found in the Hadal Zone, the deepest part of the ocean, reaching depths of up to 11 kilometers below sea level. This zone is particularly fascinating for scientists because it provides clues to how life might exist in extreme environments, both on Earth and potentially on other planets or moons. Hydrothermal vents are underwater volcanic regions where seawater seeps into the Earth's crust, is heated by magma, and then shoots back up through fissures in the ocean floor. This superheated water, which can reach temperatures as high as 400 degrees Celsius, is rich in minerals and chemicals such as sulfur. Despite the extreme conditions, these vents are teeming with life. Organisms that live here don't rely on sunlight. Instead, they use a process called chemosynthesis. Chemosynthesis allows bacteria to convert the chemicals released from the vents into energy, which then supports a whole food chain of unique creatures like giant tubeworms, crabs, and shrimp. NASA's interest in these extreme environments is tied to its search for life elsewhere in the universe. Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, are believed to have oceans beneath their icy surfaces. These oceans may have hydrothermal vents similar to those on Earth. If life can thrive in such extreme environments on Earth, it suggests that life might also exist in similar environments on other celestial bodies. The Hadal Zone and its hydrothermal vents provide a model for studying life in extreme conditions, which is why NASA has sent autonomous underwater vehicles like Orpheus to explore these deep regions. The goal is to better understand how life could exist without sunlight and in high-pressure, chemically rich environments. This research helps NASA prepare for missions that will explore the oceans of distant moons, where similar conditions may exist and where life, if it exists, could be found. The exploration of Europa, one of Jupiter's moons, represents one of NASA's most ambitious missions, aimed at potentially discovering signs of alien life. Europa is especially intriguing because it is believed to have conditions similar to Earth's deep oceans, where life on our planet may have originated. Beneath Europa's thick layer of ice, scientists believe there is a vast, salty ocean with more than twice the amount of water found on Earth. This ocean is kept in a liquid state due to geothermal energy generated by the moon's tidal flexing, caused by the immense gravitational forces of Jupiter. This flexing creates immense geothermal activity, leading to the possibility of hydrothermal vents, much like those found on Earth's ocean floors. These underwater vents are considered one of the key factors in the origin of life on Earth, as they release hot, mineral-rich water that can support ecosystems without the need for sunlight. Similar vents on Europa could potentially harbor microbial life or more complex organisms, making the moon a prime candidate for exploration in NASA's search for extraterrestrial life. NASA's upcoming mission to Europa, known as the Europa Clipper mission, is designed to study this moon in greater detail. It will use advanced instruments to scan Europa's icy surface, measure the thickness of the ice, and analyze the composition of the ocean beneath. The mission will also look for potential signs of life by examining the elements necessary for life, such as carbon, hydrogen, oxygen, and sulfur, already detected on the moon's surface. Getting to Europa, however, is no simple task. The mission faces numerous challenges due to its extreme distance from Earth and the complex gravitational influences of Jupiter and its many moons. To reach Europa, NASA will have to use a complex series of gravitational assists, or slingshots, where the spacecraft uses the gravity of other planets and moons to gain speed and alter its trajectory. This technique is similar to playing a cosmic game of pinball, carefully navigating the spacecraft through the solar system. This mission is especially exciting because it aims to answer one of humanity's most profound questions. Are we alone in the universe? If Europa's oceans host life, even microbial or simple organisms, it would revolutionize our understanding of the potential for life beyond Earth. With similar conditions to the deep oceans where life first began on Earth, Europa offers a unique opportunity to explore the possibility of alien life within our own solar system. As for the connection between deep-sea exploration on Earth and this space mission, NASA's underwater research helps scientists better understand how life might survive in extreme environments, such as high-pressure, low-temperature conditions with no sunlight, by studying Earth's hydrothermal vent ecosystems. This research informs the strategies used to search for life on other worlds with similar environments, like Europa. This mission will be incredibly complicated, but here's a glimpse of it. Let's look at the Europa mission and why it's so significant. The first phase of the mission involves the Europa Clipper satellite, and the expected timeline is that Europa Clipper will launch from Earth in October 2024. After launch, it will travel to Mars for a slingshot maneuver, using the planet's gravity to gain speed and then boomerang back towards Earth. Once it returns, It will perform another slingshot using Earth's gravity to accelerate further toward Jupiter, where it will ping-pong its way through space toward Europa. The journey from Earth to Europa will take about 7 years, with arrival expected around 2031. This entire process is mind-boggling because scientists have to calculate the exact positions of every planet and space body along the way. Every step, every launch angle and timing has to be precise because the planets and moons are constantly orbiting. NASA's engineers have programmed the mission to account for these movements, ensuring that the spacecraft reaches each checkpoint on time. Upon arriving at Jupiter, the real challenge begins. To enter Europa's orbit, the Clipper will have to navigate multiple flybys of Jupiter's massive moons, particularly the Galilean moons, Jupiter's 4 largest moons. This series of maneuvers will ultimately help the Clipper enter Europa's orbit and begin studying its environment. Once the Clipper settles in, it will take detailed readings of Europa's gravity, temperature, and atmospheric conditions. This process alone could take months, but here's where things get even more sci-fi. In 2031, NASA plans to send cryobots, or ice-penetrating robots, to Europa's surface. These robots will drill through Europa's icy crust, which is estimated to be between 2 kilometers to 20 kilometers thick, using nuclear power to melt the ice. Once they reach the liquid ocean below, they'll deploy 48 micro-robots that will swim through the waters in search of alien life. Now, imagine this. If we find life beneath the ice on Europa, how will its biology be structured? What will alien life look like? The excitement of discovering that we're not alone in the universe is truly staggering. If this mission proves successful, it could fundamentally change our understanding of life beyond Earth. The chances of discovering alien life on Europa are intriguing. The deep oceans of Europa, warmed by geothermal energy from the moon's core, mimic the conditions where life on Earth first formed around hydrothermal vents. If similar life exists on Europa, it would be one of the greatest discoveries in human history. Many space agencies have been searching for evidence of alien life for decades. With advanced instruments like the Kepler Space Telescope, Hubble, and the James Webb Space Telescope, we've searched light years into space for any signs of life. But Europa presents an opportunity much closer to home. A chance to explore a moon in our solar system that could harbor life in its dark, cold waters. It's an incredibly exciting thought, and the mission is poised to push the boundaries of space exploration like never before. Even though we've searched far and wide, we have yet to find concrete evidence of alien life. Unfortunately, there's no proof that life exists beyond Earth, yet. We're trying to study the birth of life based on how life evolved here on Earth, specifically around DNA and self-replicating molecules. But there could be other, completely different ways that life could originate. We're just unaware of them. We might be limiting ourselves by only searching based on the Earth model, which may make our search feel extremely rare or elusive. We might even be looking in the wrong places. Yet, despite all this uncertainty, some of the brightest minds on Earth, scientists from all nationalities, races, religions, and backgrounds, have come together, putting aside their differences to pursue these revolutionary missions. This unity represents the best of humanity, driven by a shared curiosity that has propelled us to become the most modern civilization on the planet. Even if we fail, these missions show the immense potential we have as humans. Curiosity is at the core of these missions, and it's what drives us to unlock the mysteries of the universe. The beauty of these revolutionary space missions is that the science and technology developed for them ultimately empower all areas of human civilization. They give us that meaning and connection, pushing us to improve and evolve. So, let curiosity be the driving force in your life. There's always so much more to learn, explore, and grow. So, what do you think? Let me know in the comments. I'd love to hear your thoughts. And if you want more deep dives into the biggest mysteries of the universe, make sure you hit that subscribe button and turn on notifications. Trust me, you won't want to miss what's coming next on Unfolded Secrets. See you in the next video.